Hello everyone. So today's topic is charge to mass ratio of an electron, E/m of an electron, a very important topic in terms of magnetic field. In this topic, we find a unit mass of a particular value of charge, a particular quantity of charge, so that charge here is defined. So let's assume the condition in which magnetic field is applied into the page and a charged particle is moved right to left. Consider this as electron. The velocity of electron is towards left side. The formula we have, F equals to Q into V into B, or in terms of magnitude in vector form we can say E into V cross B. So this V is the first vector. This magnetic field I can say is the second vector, where we have to find the direction of the force, and here we can see that we will use Fleming left hand rule. The rule says that place your left hand in the direction of the first vector, which is towards the left side, and curl the fingers of the right hand in the direction of the magnetic field, which will be inwards. So we will find that the direction of the force here we see will be upwards by placing the fingers of right hand in the direction of velocity and curling the fingers for the left hand inwards direction. We will see the direction of force will be upwards. So now the velocity of the particle is upwards. While moving upwards, it will again change its direction by again using left hand rule. Now we can see that the direction of the force has changed because the velocity of the particle is upwards and the fingers will curl into the page. We will see that it will be tilted towards the right side because now your thumb will point towards the right side. Now this is the velocity, and again using the left hand rule we will see that by placing left hand in the direction of velocity and curling the fingers into the page again, now we can see the direction of the force has changed to downwards. This way now we will use the left hand rule again. We will see the direction of the force has changed again. It comes this way while moving toward the velocity. Again using the left hand rule, we will see the direction of force has changed to upwards, and it will complete a circle. So we can say that when a particle moves in a magnetic field, there must be one condition, that the velocity and magnetic field must be perpendicular to each other. When they are perpendicular to each other, I can say that the charged particle will move in a circle. So throughout the past, we have observed that the direction of the velocity keeps changing, but the magnitude remains constant. Now there are two forces acting on this particle. According to this formula, the first one is magnetic field, and the second one is centripetal force acting on the particle. The formula for centripetal force is Fc equal to mv square upon r. The other formula we have is F is equal to E, V, and B. B stands for the velocity. As the particle is moving in a circular path, the magnetic force is providing the centripetal force necessary to keep it moving along. The direction of the centripetal force will be towards the center, and the magnetic force will act perpendicular to the centripetal force. These two forces will keep the particle to move in a circular path. So by comparing both of these formulas, Fc equals to F, I can write mv square upon r equals to EVB. We can cancel V by V square, and by rearranging this, we get E upon M equals to V upon BR. This is the equation that we can use to find the charge to mass ratio. It means that a particular material has this value of charge. Now we have to find here V, the velocity, and R, the radius. For velocity, we can put this whole setup in a tube, and we can use filament for the emission of electrons. The filament is connected to a power supply, and it will eject electrons. This will be known as photoemission of electrons. When the electron moves towards the tube, we will get kinetic energy, which will be equal to EV. Capital V stands for voltage. The other formula we have for kinetic energy is half mv square. So by comparing both of these formulas, we will get half mv square equals to EV. Rearranging it, we will get V square is equal to 2 EV upon m. And by simplifying, we get V is equal to under root 2 EV upon m. So by putting this formula in the equation, we will get E by m equals to 1 over BR and under root 2E V over m. By taking square both sides, E square upon m square is equal to 1 upon B square R square 2 EV upon m. The V here stands for voltage. We can cancel out E by E square, and we can cancel m square by m. Only one m and E will be remaining. So E by m will be equal to 2V over B square and R square. This will be formula that we use to find the value of charge to mass ratio of an electron. Charge to mass ratio means that a particular quantity has this value for charge. So this V is voltage that we will use to heat up the filament and eject electrons. R is the radius of the circle. So now we will work on finding the radius. As we have made the whole system in a vacuum tube, the vacuum tube is filled with hydrogen gas. Hydrogen gas is filled at low pressure. When these electrons will enter into the magnetic field, cross means that it is into the page. According to this formula, we will see that the force is perpendicular to magnetic field and the velocity. So this particle will start moving in a circle. We will again use a tube. When charged particles are entering into the magnetic field, they will start moving in a circle. Magnetic field is applied into the page. We have filled this tube with hydrogen gas at low pressure. These are the atoms of the hydrogen gas. When an electron enters the tube and collides with hydrogen atoms, it will excite them. Consider this is an hydrogen atom. When an electron will strike to the bound electron of the hydrogen atom, it will excite it. It will move in a circle. It will move to the higher shell. When it de-excites to the lower shell, this will eject a photon. This will eject light. That whole part of the electron will start glowing, which will illuminate this whole path, and we can see the whole circle in a colored form. It mostly appears blue. Then we can use a scale or a meter rod to calculate the radius of the circle. Now we are able to calculate the radius and also the velocity from this formula. So we can finally get the formula E by m equals to V over B square and R square. We can also put the value of velocity here, R square, magnetic field that we applied here. By putting all of these values, we can get the charge to mass ratio of an electron.